We're going to talk a little bit about R600, some of the uses. We got a couple of videos to watch. We got some different a couple of different other things that we're going to go over. I do not have a Lokring set, but we're going to make do without it. Thank everybody for your time today. Let's go ahead and get totally started. All right, so here, let me share my screen here. Whoops. Okay. So whenever we go start talking about the Lokring set, one of the things that goes along with this Lokring set is this LRSZ tube cutting pliers. Those are very effective tube cutting pliers. They literally do not have, you don't have to do a 360 degree cut. It's just 180 degrees. Okay. So how do I take care of that? You know, the first thing I need to do is I need to mark my tube. So I'm going to mark it. I may mark it with a piece of tape. It may be that I draw. If I have a Sharpie with me, I may use the Sharpie to mark it from where I'm going to do it. Then I'm going to align my tubing cutter. I'm going to place one hand over where I'm going to be cutting. I'm going to use it as a guide. I kind of hold my knuckle up like this with it, and then I use this and I use that to guide that tubing cutter in. And like I said, it's only about 120 degrees that I have to have that this will to cut this tubing cutter. The tubing cutter that I have, other tubing cutter that I have from my days as a compressor changer, I literally had to have a 360 degree tubing cutter. So this is really great. It's not cheap. I'm not going to tell you any stories, but you get what you pay for. As long as I take care of this tool, I'm going to get probably 3-4 years out of it. And then that time I'm only going to have to change the blades. Okay. Whenever my tubing cutter gets too dull for me to cut through, I'm gonna need to change the blades out. So like I said, I've placed my one hand alongside the cutter. Then I'm going to use the fingers to maintain the cutter position. Okay, I'm going to apply the moderate pressure to it, and then I'm going to need at least 120 degrees of rotation in it. Here's a perfect example of it. I don't lay mine out like this. I actually like to take the tubing cutter, put the tubing cutter right here, and I roll my finger around it. Disadvantage, some people like it this way. I prefer it the other way. You do have to be careful because you can cut yourself if I'm not maintaining the constant perpendicular position. Okay. I do not want to apply side torque to it. It needs to be a straight up and down motion. I'm going to use my free hand as a guide, like I showed you right there, and then I'm going to do not apply excessive pressure. The one that we had, I did a class over in Dallas, Texas, and if you look at that wheel, that's exactly what happened. That was a chip that had been knocked out. The reason they had chipped that is because they had put excessive pressure on it. Okay. It will break or chip the wheels, and it's because of an operator error, and it's not covered under your warranty. So I have to place it. So if I am one of the technicians and I'm new to this, I'm gonna have, if I'm the lead tech, I'm going to have my technicians cut a bunch of tubing with it. Okay. I'm going to replace the cutter wheel. There's your part number on L13001304. Okay. I can, if something happens and I have to replace the pins, okay, that part number is L1400981. Those are the pins. I shouldn't have to replace the pins because I never actually remove the pins. All I do is tap it out so that I can get the cutting wheel out. So I should never lose the pins. Okay, so like this right here, I'm going to drive the pins out from the non-logo side. Okay, I'm going to show you the non-logo side in just a minute. Okay, retaining pins are tapered. Okay, those holes are tapered. So driving the pins out incorrectly will destroy the tool, and I've just bought a new tool. Okay, so the drive the pins just far enough out to remove the cutting wheel. Okay, then I can replace it, and I'm going to tap them back into place. Okay, I'm going to turn it over, and I'm going to tap them back in using a hammer. Okay, I do not put it all the way in. Okay, I'm just going to put it so that I don't have any. I have it driven all the way through, and it's sticking out the backside. I'm not doing it flat. There will actually be a little bit of a ridge in it. So I'm going to drive these in from the logo side. Okay, if I drive the pins in too far, it will destroy the tool. Okay, pins should not be driven flush. Okay, verify that the wheels spin freely. What will happen is, if I drive the pin in too far, it won't freely rotate, and I also am destroying the tool. So here's a picture right here of the logo side and the non-logo side. Okay, the logo side, the pins slightly protrude. Okay, the non-logo side, the pins are recessed. So you can see them right there. Okay. So if you have any other questions, or you want some more information, you can either send me an email, text me. You can go to www.vulcan.com. That's one of the other things that you can do. If you have any questions, please let me know. Okay, so the next thing we're going to talk about, okay, is the aluminum connector. Okay, so this is the Lokring Type 50 connectors. All right, so here's a picture of that connector. You notice that it is it is aluminum all the way around. Okay, so if I have any questions, this is actually available on the Lokring website, that www.lokring.com that I just showed you. This all is available on that website. There is also the presentation that we're going to go and view here in just a minute. Then if you have any other questions at the end, we'll come back and huddle back around. One of the other things that we're going to talk about is the Lokring, the safety data sheet. You're gonna have to pardon me. I have the whole right side of my face is numb, so it's a little interesting here. But this is also available on the website, so you can go there. So one of the things that I wanted to add, this is okay. That's it right there. www.vulkan.com. Okay, that will tell me exactly where I am. Okay, so I'm going to go down. We're going to go and I'm going to share the screen. I think this is the right one. I have two programs. Go ahead. That should be right now. I'm going to start it. Oh, I got to turn the volume up.
Hello everyone, I'm Jeremy Hedges with American Vulcan Corporation, and today we'll be reviewing safe handling of flammable refrigerants. In this case, R600A, which is the refrigerant contained inside of our Sub-Zero under-the-counter refrigerator that we'll be working on today. We'll be utilizing our American Vulcan charging kit to both extract and to charge the hydrocarbon refrigerants back into the system. As you all know, hydrocarbons have become very popular refrigerant of choice from manufacturers to meet environmental impact requirements. The R600 we'll be dealing with today has an ASHRAE 34 classification of A3, meaning it's A for non-toxic and 3 for highly flammable. And keep in mind that all hydrocarbon refrigerants are going to be classified as A3 refrigerants. Some other common refrigerants that you'll deal with that are flammable will be R32, R452B, R600 as we'll review today, and also R290. Most of these refrigerants are going to be seen in the commercial aspects, and R600 is what we'll see in residential refrigeration. And that's pretty much what our American Vulcan charging kit has been designed to handle. It's going to be anything with R600 for residential appliance. As I mentioned during my introduction, today's focus is going to be on the safe handling of flammable refrigerants. In this case, the refrigerant is inert when it's inside the system because it has no oxygen in it. We need three things to sustain a flame. We're going to need fuel, which in this case, the R600A. We'll need air, oxygen, and we'll need an ignition source or a flame. Sudden release of the refrigerant from a cabinet or from an appliance could result in flash fire, a sustained fire, or even an explosion. The most risk is contained in an internal leak inside of the cabinet, where the gas could actually be introduced into the air that's already contained in the unit. And if an ignition source was present, that could be the potential of an explosion. Keep in mind that it's a very small mixture, a small ratio that we have to hit in order to create this flammable environment. It's referred to as our lower explosive limit or lower flammable limit. In the respect to R600, it's a 1.8% concentration limit, meaning we need 1.8% of the R600 to combine with the remaining oxygen in order to promulgate a flame. If we get to our upper explosive limit or upper flammable limit, which would be at an 8.5% concentration level, we actually have too much fuel to promulgate a flame. So just like I mentioned inside of our system being pure R600A, theoretically, it can't ignite until we introduce air. A technician can do that by cutting into the system and allowing air to be introduced. So just like with our traditional refrigerators and appliances with our standard refrigerants such as 134A, all the regulations associated with hydrocarbons will be controlled through the EPA and SNAP regulations. One of the big changes that you'll see is no retrofitting. In a case of a retrofit, you may be taking a 134A refrigerator and trying to convert it to an R600. Keep in mind, this is currently illegal. And the reason for it is that the R134A refrigerator won't have the intrinsically safe devices like timers and switches that are commonly used with flammable refrigerants. So you could inadvertently convert a refrigerator and it's chocked full of flammable or ignition sources that could present danger to both you as a technician or the homeowner themselves. There are some changes, however. You're going to see a lot more warning labels all over the appliance, including some R600 labels by the compressor. You'll have labels by the evaporator and also on the outside of the cabinet. These labels are meant to allow the homeowner and the technician both know that there's risks associated with this refrigerant. As a technician, there are two really good resources that you can use for additional hydrocarbon safety tips and guides. The first is AHAM, the Association of Home Appliance Manufacturers, and RSES, Refrigerated Service Engineering Society. AHAM has written an instruction for appliance technicians on recommended methodology on how to handle R600 and other hydrocarbon refrigerants, and would highly recommend that you take a read. RSES's textbook on hydrocarbon safety is filled with tips and tricks on handling hydrocarbon refrigerants safely, as well as all of the charge limits for all of the equipment available and dictated through the EPA. At this point in the presentation, we'll be going through our pre-safety check that is in alignment with our AHAM guidelines. The first thing we'll want to do is ensure what type of refrigerant we have in the appliance. In this case, it is R600A, which can be verified on the manufacturer's label plate. We'd also want to have on hand the MSDS associated with that refrigerant in case we need to render any first aid. The next very important piece that's going to help the technician monitor the environment is going to be a combustible leak detector. This leak detector will be used initially just to search for leaks on both the inside and outside of the cabinet. And then we'll continue to leave this leak detector on to monitor the environment as we service the equipment. Next important piece is going to be a fire extinguisher. Just in case we have an incident, we want to be prepared and have firefighting equipment on scene. Another component that we're going to be utilizing is a tube cutter for the removal of all of our tubes. We'll no longer want to use a torch, since this could be the ignition source that would promulgate a flame. The other portion we want to consider is maintaining a well-ventilated area. We're going to do this today by introducing a floor fan that's going to help bring fresh air into the environment and prevent us from ever reaching the concentration of our lower explosive limit. This should help mitigate any flame should we have a leak in our system while we're working on it. And finally, we're going to want to eliminate all of our ignition sources. Some of the obvious ignition sources that we have could be a homeowner who smokes, matches, maybe they have candles throughout the home. The torch itself, the spark lighter you're using to actually ignite the torch, all of these would be very obvious ignition sources. But the first tool we grab as a technician is often a cordless drill. If we hadn't done that pre-safety check with our hydrocarbon leak detector, we may not have noticed that there was actually a pool of gas inside that cabinet. And as soon as you hit the trigger on that cordless drill that's a brushed motor, that could be an ignition source. So that's where we're talking about. Some ignition sources are not as readily apparent as others. So keep in mind, do you have an intrinsically safe tool that you're using? The vacuum pump itself, is it rated to actually work around flammable refrigerants such as A2L, A2, and A3 refrigerants? Now we're moving into leak detection and line repair. And through following AHAM guidelines, we're going to start with only using a tubing cutter to remove any of our tubes. Like I mentioned previously, the torch is going to be considered an ignition source, so we need to move away from that and simply cut all of our tubes. We want to use a certified leak detector, preferably an electronic leak detector when trying to identify these leaks in the system. Keep in mind that R600 on the low side runs in a vacuum while it's running. So if you use soapy bubbles or some type of external fluid to detect leaks, this could be drawn into the system if the system has a significant leak on the suction side. So please keep that in mind, that before running a system, you would want to clean any of those soap bubbles away from the suction side of the system. You can also use dry nitrogen to pressurize the system and to create almost a trace gas using the R600 that's in the system. One of the big benefits of working with hydrocarbon refrigerants is now to find a leak, we can just add nitrogen immediately to the system to raise our pressure to around 100, 110 psi to facilitate the use of an electronic leak detector. This should allow us to, in a more timely manner, identify the leak. In the past, we had to recover the refrigerant if there was any remaining, and then add a small trace amount of the refrigerant along with dry nitrogen. We can now eliminate this step because R600 can be immediately released to the environment after we're done with our leak check. One of the major aspects that we want to continue to monitor while doing our sealed system service is going to be constantly monitoring for a flammable environment. We're going to do this by using our electronic leak detector, leaving it in the on position while we're performing our service. If we get a leak, this should start to alarm and allow the technician to know that something has happened to change the environment and that it potentially could be flammable. As we continue with the leak detection and line repair, at some point we're going to have to remove the gas from the appliance. In order to do this, it's much easier to directly discharge the gas straight into the environment by using our discharge hose and routing it through a window or door. If this isn't an option, then using a temporary container such as a recovery bag or maybe even a recovery cylinder would be more appropriate. Keep in mind that if you use the bag or the cylinder for temporary storage, you want to discharge this immediately in a fresh air environment that is free from any ignition sources. Another component we want to stay away from is compressed air. Just like with our traditional refrigeration systems, we're not going to use any compressed air or oxygen for flushing the lines or blowing away debris or cleaning. Keep in mind that pure oxygen is an oxygenator and can be flammable in the right circumstances, and especially in introduction of petroleum-based products. Always use dry nitrogen if you need to flush your system. There are red marks that are going to be located near the process tubes on the appliance. These need to be maintained on the system. Some manufacturers use heat shrink sleeves, others will use actual paint to indicate that this is a flammable refrigerant inside of this system. So it's just an additional warning or visual indicator for the technician that there is indeed flammable refrigerants in the system. Always remove your piercing valves. This hasn't changed. Even with HFCs and traditional systems, you're always supposed to remove your piercing valve after service. They're always going to be a potential for leaks and should be removed and filled or the tube repaired after this service is completed. During the refrigerant removal phase of our service, we're going to want to ensure that we maintain ventilation. Again, having that floor fan or an intrinsically safe fan nearby to bring fresh air in will greatly prevent us from ever achieving that lower explosive or lower flammable limit we talked about previously. We want to maintain our proper grounds once again, and of course verify that we are using a refrigerant that is legal to discharge into the environment. If you're using R32 or R452B, you're going to need to actually recover these since they are HFC refrigerants. If you use a temporary vessel, such as a recovery bag or a recovery cylinder, you do need to ensure that you empty this before you transport it anywhere. There's no point in putting a full recovery bag or full recovery cylinder filled with a hydrocarbon refrigerant that is no longer useful. Just simply discharge that into the air in an area that is risk-free and free of any ignition sources that could potentially ignite the gas. And of course, if you're using your equipment, hoses are going to be a big part of this. We're going to have quite a system of hoses. You want to ensure that they are all compatible with the refrigerant that you're using and are adequately long enough to either discharge outside of the home or to reach whatever recovery device that you're using. In recharging and replacing refrigerant inside of an appliance, the first thing we're going to want to do is match the refrigerant type. Again, as mentioned previously, this will be found on the manufacturer's label plate. In this case, we're doing R600A, and it has a charge quantity of 1.2 ounces. So obviously a very small charge. You'll see that there are significantly smaller charge volumes when dealing with R600 than you previously are used to with traditional HFC refrigerators such as a 134A refrigerator. We want to ensure that all of our electrical faults or problems have been repaired and placed back into operable condition before actually accessing the sealed system. Remember, anything electrical could be an ignition source, so let's repair that from the beginning, and then we can move to our sealed system repairs. Keep all our grounds in place, and make sure that as we're cleaning up or if you're accessing lines that you don't use any corrosive cleaning chemicals such as ammonia or bleach that may impact the actual service life of the copper tubing. It can degrade that over time. So try to It is appropriate to torque those down. You can buy a small torque wrench that will actually torque the cores to the recommended specification. And finally, once we've completed all our service, repairs, and inspection of the appliance, we want to make sure that all of the safety labels are still intact, and of course also the red markings on the process tube. You can again use heat shrink to place over the tube to indicate this, or use epoxy paint. The installed ventilation features, you must remain intact. You know, a lot of technicians don't understand that piece of cardboard is the true ventilation system on the back of that refrigerator. That helps to direct airflow across the condenser and across the condensate pan. This is also one of the locations where R600 could pull inside that condensate pan. If you had an inside the cabinet leak, you could literally come down the condensation drain and collect inside the condensate tray and remain there for some quite amount of time. R600 is a very heavy gas, and therefore can be still in whether a deck drain or a condensate pan. Any of those locations could house some refrigerant that leaked either from the service that you performed or a leak that was in the appliance previously. Another thing to note is when you are getting ready to open a sealed system is that just because you've recovered all the refrigerant doesn't mean that there's still not refrigerant in the system. Up to 50% of the refrigerant charge can remain emulsified in the refrigerant oil in a system that's been inactive for a long period of time. Couple that with lower ambient temperatures, and you can see even more of a charge remaining in the oil. So keep that in mind during your service process. So we're getting ready to unbox our American Vulcan charging kit, also known as our US charging facility. We're going to go over all of the components contained in this kit that are going to help technicians safely perform a charge and recovery of any flammable refrigerant that you may encounter on a residential refrigerator. So the first component we're going to talk about is the actual discharge hose that comes with the kit. It's actually strapped right to the lid of the kit, and this is for the removal of refrigerant when you can discharge outside of the home. You could either route the weighted end of the hose outside of a window or through a door. Just be sure to always verify that the area where you'll be discharging the refrigerant is free from any ignition sources or high traffic. Next component we're going to take a look at is our electronic scale. Our scale has resolution available in grams or ounces so that you can easily convert in the field to whatever resolution or scale is used on the manufacturer data plate. Next component that we're going to discuss is the 4 accessory hoses that come in the kit. And those are utilized to join both individual single valve manifolds into one manifold assembly, simulating a 4-valve manifold assembly. Next component we're going to talk about is our low side manifold gauge. This gauge has a much higher resolution on the vacuum portion than your standard R134A gauge. The maximum pressure on this gauge is 45 psi, so be very careful. If you hook this to a 134A system, there's a high likelihood of creating an overpressurization and permanently damaging the gauge. Next component we're going to take a look at is going to be the high side manifold gauge. This gauge has a maximum pressure of 140 psi. So if you hook this to a 134A system that is in operation, you have a high risk of overpressurizing the gauge and permanently damaging it. Also, for mounting to the manifold sets, we do have 2 mounting hooks that will easily thread to the back of the manifolds, and that will allow you to conveniently hang the manifold sets from the appliance that you're servicing. The next component we're going to take a look at are our Schrader core depressors. It's a very handy tool that can conveniently turn any process port into an open and closed valve. Also included in this kit are 2 ball valves. One ball valve has a 1/4-inch SAE male and a 1/4-inch SAE female connection port. The other ball valve has 2 male 1/4-inch SAE ports for easy connection to your standard refrigeration hoses. The next component we're going to discuss is our bottle adapter. This is used to adapt our R600 refrigerant cans to a 1/4-inch SAE flare so that we can hook our refrigerant hoses to it. Please keep in mind that the adapter is made from aluminum and the can has steel threads, so be very careful when you're threading the adapter onto the bottle. We also have 2 T's included in the kit. One is for the adapting to our liquid charging stand, while the other is utilized to create a small manifold, which will allow us to both evacuate the system at the refrigerant bottle and the appliance itself. We also have 2 more longer hoses that are installed in the kit. They'll be attached to a check valve. This check valve is designed so that during the charging process, refrigerant can't flow backwards and back into the can. Please also note the directional arrow that's on the check valve. This is very important that the arrow should be pointing away from the refrigerant bottle or away from the source of the refrigerant that you're trying to charge into the appliance. So we've completed our review of the AHAM recommended procedures for handling R600 and other flammable refrigerants. So the first thing we're going to get into with our hands-in process is actually start our preliminary check. So we have our locator, which is a TLD 500, which is produced by Vulcan. This is our refrigerant leak detector, which also does detect hydrocarbons. So this is an all-in-one. It will go through a warm-up process that will take a brief 30 seconds or so, and then you'll hear indicated by a tone that it's actually functioning. Preferably, you'd like to take your electronic leak detector out to a fresh air environment to calibrate it. Obviously, here in studio, we haven't had a sealed system open yet, so we do know that it is a fresh air environment, so we'll allow it to calibrate here. So as we get our pulse, the TLD 500 will announce a constant chime as it's powered on. So this becomes our indicator that our environment is free of any hydrocarbons and we're not at risk of reaching our lower explosive or lower flammable limit. So I will internal of the cabinet, So back by the vents where our evaporator would be located. Just make sure you don't get any continuous tones from the leak detector. With a lot of airflow, because the unit's running, you may get a couple fluctuations, but as long as we don't get a continuous tone, it should be free of any leaks. Focusing around the evaporator, come down to the condensing unit. Keep in mind with R600, it is a heavy gas, so predominantly it'll be found near the bottom of any of your components. I'm not getting any indicators on my leak detection system, so I'm going to let it continue to remain powered on. For video purposes, I'm going to go ahead and silence our locator just to not have the beep. I would highly recommend when you're performing your real service that you leave the beep audible, so it's not something you have to look at periodically. But to silence it, I just push the silence button here. And I'm just simply going to place it down on the table and allow it to monitor, placing the sensing probe near our work area so it can monitor for any discharge of R600A gas.
Okay. Okay, that should have. All right. Hope everybody enjoyed that. So, a couple of things that we want to be very careful of whenever we're dispensing R600 into an open area. I've got to ensure that I have no flame. It's got to be vented outside the house. If I actually, if I have the right mix of gas to air, and the only thing that I'm needing is a spark, if I turn a light switch on, I have a spark. So you need to be careful. It's always needs to be vented outside. Excuse me. I have heard of somebody that was changing out a compressor and they vented it outside just like they're supposed to at an apartment complex. So it was vented outside. Somebody came walking by with a cigarette lit and ended up igniting the gas. So you got to be very careful. That's the reason I always recommend putting it into a bag. With the bag, the only thing that I have to worry about is that whenever I get out, I get into the open air, I'm sure that I have nobody around me. I look around, then I uncork the bag and I start to roll it up, and I just don't want to ride around with that in my truck. If I do that, I am a ticking time bomb. I'm sorry. Looks like I'm having a wardrobe malfunction. But you want to make definitely doubly sure that I have no way to ignite myself, anybody around me, any home, any apartment. You just got to be sure that you're not having any issues with that. Okay? So if that's the case, then I'm ready. If I'm not going to dispense my bag, I'm going to find some place that I can pull over and let me get it taken care of and vent it into the air. Okay. I do have another presentation here. So we have the part B of this. So I am going to go ahead. Let me go ahead and come right here. Come here. Go share screen. Should be this one. And start. And Start.
have process stubs mounted to this piece of equipment. In the field, it's probably going to come with crimped off process tubes. For training purposes, we already have the process tubes on. So we have our suction process tube and our discharge process tube off the dryer installed, as indicated by our red tape. We know that there's flammable refrigerant inside this unit. So the first step will be to discharge the refrigerant. If you have a compressor that is functioning and working, we recommend that you warm the unit up for about 5 minutes prior to starting this process. That'll help to break the bonds between the refrigerant and the oil and allow you to get more of the refrigerant out of the system during the discharge process. If you're just replacing an evaporator or a component and you can run the compressor, you can use the compressor to help aid you in the discharge of refrigerant. If it's a non-functioning compressor, obviously the ambient air temperature is all you're going to be able to rely on, and you'll do a passive type of recovery. So I want to make sure that this is all the way back seated. It even says open close on the back of the valve. This will prevent us from installing this and the Schrader core being depressed. So all I have to do is go ahead and run my core, get it nice and snug, and then the system's ready to go. The Schrader core is still closed. Obviously, no refrigerants coming out. We're not indicating anything on our leak detector. We can go ahead now and hook our discharge hose up. Again, if we were discharging to the exterior of the home, this is our discharging hose, which comes with a weighted end. We can go ahead and hook directly to the unit, run the hose outside, start the compressor, and start the discharge process. In this scenario, we'll be using a standard accessory hose, and we'll be charging to a recovery bag. So the first thing we'll do is we'll lay out our recovery bag that we'll be using today. Obviously, with recovery bags, they're temporary recovery cylinders or bags in this state. The bag does need to be inspected. So periodically, you do want to check the bag to make sure that there's no rips or tears in it. This is a double-lined bag, so it is very durable. Go ahead and hook into the bag, and we'll leave our valve shut. And again, a valve isn't necessary, but I prefer to have anytime I can have a quick access shut-off valve, I prefer installing them. So I do keep that on my hose. It lets me isolate to the bag quickly. So we're going to go ahead and thread in our Schrader core depressor. This will allow my refrigerant to flow to the hose up to my valve. And after I open this valve, you're going to hear the refrigerant start to discharge quite rapidly into the bag. That is one thing I like about utilizing a recovery bag, is because you can hear the refrigerant and essentially the state of emptiness of the refrigerator, so to speak, just through the auditory tone. So it is helpful once you become experienced as a technician to listen. So I'm going to try to be quiet for the remainder of this portion so you can actually hear the refrigerant flowing. All the way front seated. And then as soon as I open this valve, we should start to hear the refrigerant flow. Now that you can barely hear the refrigerant flow, this is usually where I'll close my quarter turn valve and I'll let system pressure kind of build back up a little bit. Since we still have the capillary tube not pinched off, there's still a little bit of a Venturi effect, meaning the refrigerant will flow through the system, through the capillary tube, and take some time to build pressure up. So as I open my quarter turn valve again, you'll hear another sudden surge as pressure has built up in the system. And then I'll shut it again. And I'll continue to do this a few times until my system no longer discharges. Now, to aid in this, since we have process tubes on here, we could attach our suction gauge and monitor our suction side pressure as well. But as you get experience with using the recovery bag, a lot can be told just by the auditory. So here we go again. I'm going to open the valve. You'll hear another discharge. The other thing you can do while you're discharging is you can reach into the unit, tap the compressor a little bit. That'll help free some of that bond between the oil and the refrigerant. There's our capillary tube. So normally we'd take our pinch off pliers if we were going to actually replace the dryer, and I'd simply come into the cabinet and I would just pinch off the capillary tube. That'll direct all refrigerant flow through my hose and into the recovery bag. If we pinch it off, it can no longer go into the system. It has to come through the process tube, through our Schrader port depressor, through our charging hose, and into our recovery bag. So once I open this valve again, you should hear another discharge since we haven't been discharging into the bag for a little bit. And as you can see, it continues to get less and less and less as we discharge the unit with the aid of the compressor, getting to the point where I hardly hear anything at all, which is telling me as a technician that it's safe to go ahead and stop the recovery process and go ahead and open up my system and perform any component replacement that I need to. Again, as an added safety to technicians, especially one that is new or isn't using a recovery bag, you can always hook your suction gauge up to the suction port and monitor the suction pressure to ensure we're getting to zero or into a vacuum. If you would like to hook a suction gauge up, we already have a service port here, so we can always monitor our system pressure by hooking our suction gauge manifold. Now keep in mind with R600, if we weren't actually recovering, I would not want to hook this gauge up because again, R600 is on a vacuum on the suction side. If I hook this to a functioning system without evacuating my manifold first, I would basically suck all of the air and non-condensable gases directly into the system. So keep in mind, for troubleshooting purposes, you will need to evacuate your gauge set before you ever hook it to the low side of the system. So I have my suction gauge manifold all hooked up. Our suction hose goes to the bottom of the gauge manifold. And I'm not going to use a Schrader core depressor, but I do need to ensure that the hose has a Schrader depressor installed so that I can actually get a reading. And you can see the gauge instantly fell into a vacuum. And that's what I was saying. Even though I didn't have a gauge up, I was confident that we had removed the refrigerant just by the sound it's making in the bag. And of course, that's going to come with some experience. So until you get that confidence, go ahead and hook your suction gauge up. It's not going to hurt anything. We're recovering the unit. Any air and nons is going to be sucked into the system and discharged into the bag. We'll perform our service and we'll evacuate everything anyway. But this gives you that extra safety of knowing what the system pressure is. So our unit's back on and running, and you can see it's starting to pull down even further into a deep vacuum because there's no refrigerant left. Almost down to 29 inches. So the compressor is in great shape. And one more time, we'll go ahead and do a discharge to the bag, and you could hear nothing, which is obviously indicated by the gauge. We would expect to hear no more gas discharge. But that is basically the complete discharge or recovery of our R600. So at this point, I'll leave my valve and hose assembly attached to the bag. I'll simply back seat my Schrader core depressor, and then I can safely disconnect the whole assembly. With this whole assembly now disconnected, I have no fear of loss of refrigerant. I can take this bag outside into a safe area that's free of any ignition sources and discharge the R600 into the atmosphere. Okay. So here we are outside. We've come to a safe location with limited foot traffic and no ignition sources, so it's safe to go ahead and tear down our recovery bag. So the first thing I'll do is remove my hose, and I want to open any of the valves just to make sure that the R600 can flow freely through the hose. And the next step I'm going to do is I'm going to need to remove the Schrader core that's in this bag. It's there to prevent the refrigerant from discharging out. So I'm just going to take a Schrader core removal tool, and it's actually a torque tool as well. And I'm just going to simply remove the Schrader core. And then remove the core. So I'll just turn the bag over. Again, remember, refrigerant's heavier than air. And just start rolling it up. Something to note while we're getting the refrigerant out too, that the bags only hold just over 12 ounces. It seems like a really big bag, but it doesn't hold a lot of refrigerant. The whole key with a recovery bag is that it should never become pressurized like an actual recovery cylinder. So do pay attention to the volume of the recovery bag that you're working with and how much charge is in the appliance. We just want to get as much as we can. I do regular maintenance every now and again. I will put our bags under a vacuum just to pull everything out of them, and also to ensure that there aren't any holes or leaks in it. It's a pretty effective way to leak test your bag, since you don't really want to pressurize it, since you could just weaken the joints. And that's it. So we're at the point now, we've done our preliminary checks. We've gone ahead and recovered all of the refrigerant from our appliance. So now we're getting into the actual charging. So we've replaced our components, we've installed a new filter dryer, and we're going to go ahead and charge the system. Before we do that, we're going to need to at least get our entire hookup of our charging kit, and then we're going to do an evacuation so that we can test all of those connections. So we'll open up our kit. First thing we'll do is we'll get our low side gauge out, and we'll take the hook and we'll go ahead and get it installed. I'm just going to mount it here for now. So just like a typical gauge manifold, the bottom port is the port that connects to our appliance, and any of the side ports is for the transfer of refrigerant, or it's for hooking to the other gauge. Now, quite often technicians only want to use one gauge. If they're not troubleshooting, they're simply going to be just recovering or charging. They may only want to use the one gauge. If you know the system has no restrictions and you just did work on it and it's maintenance, you could only do one hookup. But today we're actually going to hook both the low side and the high side up so that you can see how to deal with the liquid refrigerant that will get inside the gauge manifold for your high side. All of that refrigerant does need to go back into the system. Remember, R600, it's very small amounts of refrigerant, and every one of these appliances will be critically charged. So we do need to account for all of the refrigerant going into the system. We do want to notice on this gauge, the resolution on the low side of this gauge is much larger than you typically see for a standard refrigeration manifold. Keep in mind that with R600 running constantly in a vacuum, you want a higher resolution on this low side. The other thing you want to notice is that the max pressure that is on this gauge is 45 PSI. So if you try to hook this to a 134A system, you very well could overpressurize the gauge. So keep in mind that both this low side gauge and our high side gauge are going to be utilized for R600 service only. If you put it in, again, the range on the high side, you're looking at 140 PSI, and the resolution for the vacuum is still what you would typically see on a normal gauge that you're used to for 134A. So our kit will come with 4 accessory hoses, and this is for mounting our gauges to one another as well as to the system. And I'll go ahead and I'll grab a Schrader core depressor. I want to make sure that the hose without the Schrader depressor is hooked here. Then we can go ahead and install to the other side of our manifold. And I'll do the same thing with the high side manifold. And I'll hook its Schrader port, Schrader depressor up, and I'll hook to the bottom of that gauge. I do it like this just so that I know instantly where the hookup and which hose goes to the appliance. Some people do color code these hoses. They prefer to have red tape to go here and red tape and then red tape. So it just keeps it easier for them for the hookup. But eventually with practice, you really don't need that. So the next thing we will do, we'll be charging this unit. Since it's only 1.2 ounces of refrigerant, we're actually going to be charging in a vapor, so we'll leave our bottle upright. If this had 40 grams or higher, we would actually need to charge in a liquid because condensation will start to form on the bottle. But since this is a relatively small charge, we'll actually be charging in a vapor today. The next part is our T portion. This is going to create a manifold to help us hook and convert our single gauge manifolds essentially into a 4-gauge manifold set. So all I have to do is hook to our T. We have one double male connection, which will go on the female side of the T. And this will be my evacuation port, and this will become my refrigerant supply port. So this will basically the large accessory port, or the 3/8 line that's on a 4-valve manifold, and the 1/4-inch line that you typically see on a 4-valve manifold. And then that's what we've recreated. We need to hook our high side and low side gauges together. So there is a Schrader core inside here. So I want to make sure, again, I use the Schrader core depressor to hook to the accessory port on my suction gauge manifold. And then this will just hook to the accessory port on the high side gauge, effectively linking them together. So now this has become just like a standard 2-valve manifold, but we've used a hose to bridge the two together. The next hose that comes in the kit is our charging or refrigerant hose. It does have a check valve installed, and it does have a direction of flow. So we want to make sure arrow is directional flow is this way, which means it's going to flow from our bottle to the appliance. So I want to make sure that arrow is lined up in that direction. And then since we're doing a vapor, come to the back side, and I just hook to my bottle. Make sure my valve is closed, and I can simply thread the bottle onto my can. Keep in mind that the can adapter is made from aluminum and the can is steel. So if you just swing this can onto the adapter, you have a very high potential of stripping the threads in your can adapter. So always be careful when you're actually installing the adapter. And again, that's going to hook to the refrigerant side of my manifold. I'm going to come over to my vacuum pump and get my vacuum hose. It is recommended that you put a ball valve on your accessory hose you use for evacuation. That will allow you to secure the valve while the system's under a vacuum, preventing any oil from being drawn into the hose and contaminating your hoses. And I'm going to hook that to the vacuum portion of my manifold. Make sure all the connections are good and snug. And then we have my final connection hose, which we simply hook into the side port of the suction gauge manifold, ensuring I still have a Schrader depressor, because there's going to be a Schrader core if it's not been removed on the side. In this case, the Schrader core depressor has been moved to the side. So we still have a Schrader depressor. We're still good to go. So this is the entire hookup of the system. And now I can simply take my high side gauge, which we've already have hooked up. My Schrader core depressor is already attached. The only thing I want to verify is that I'm all the way in the back seated position. So all the way to the left, it'll stay closed right on the back side of the valve. And then I can install Schrader core depressor. Again, the valve core has not been depressed. It's not open to the system yet. It's simply acting as a closed valve. That's the great thing about Schrader core depressors. You basically turn a Schrader core into an open closed valve through the use of this tool. And again, I'll take my suction. So again, making sure I'm all the way back seated on my knob, and we simply install it to our suction side process tube. And there you go, nice and snug. At this point, I'm ready. I have both my gauges are hooked up. Both side valves are secure. I don't need anything going to my vacuum pump at this point, and I don't need anything coming from my refrigerant. So I make sure that all my valves are closed at this point, and we're all hooked up. What I want to do next is check all my connections. Since we have quite a few connections and hoses here, I'm going to go ahead and run my vacuum pump and then set my low pressure gauge pointer to wherever the ultimate vacuum lies. So whatever the capacity of my pump is should indicate on the gauge. We'll let it run for approximately 5 minutes, and then we're going to shut the pump off and do a standing vacuum or vacuum rise test to see if we have any leaks anywhere. There's no point getting into the system and then determining you have a leak in your hose or your setup. We want to find that right away in the evacuation process, or it could take extremely long amount of time. So that, we'll switch our pump on. I've got a valve on the hose, which is open, so my vacuum is coming through my hose. I'll go ahead and open my manifold. It comes up to my low side gauge. Need to open my valve manifold. You see it instantly drop down to a vacuum. I'm going to do the same thing on the high side. Instantly drop down into a vacuum. Then I'm going to go ahead and open up. We're going to make sure my refrigerant bottle valve is shut, and I'll open my port to the bottle. Not pulling any refrigerant, but I am evacuating all of my hoses up to the point of the bottle. Make sure those connections are snug as well. And when we're at this point, we just want to take basically a quarter turn in on our Schrader removal or Schrader depressors. The reason for that is if there is a small void in here, and when it's fully backseated, there's no vacuum being applied to our last connection, which was the Schrader core depressor to the process tube. By front seating it, I allow the evacuation to occur all the way to this point, therefore testing all of my connections. And then I'm going to set that reference pointer right on top of my needle on the low side gauge. Since I've already established the pump's output, I know that a dry system after time should reflect the ultimate vacuum output of our vacuum pump. And what I'm doing is I'm leak testing all of my connections now. All I have to do is let the pump continue to run, isolate the valve at the pump itself, and make sure we don't get any rise in vacuum. Usually 5 minutes is adequate. If you see no rise, all of your connections are good, your hoses are tight, and you're ready to begin the evacuation process. So at this point, I don't see anywhere where I've had a rise. For video purposes, we're going to cheat a little bit, and we'll advance from the 5 minutes. So we'll go ahead, open our pump supply valve. So now we're pulling vacuum again to the system, and I'll go ahead and open front seat my Schrader core depressors. And we do that a little slow, just in case there was any residual refrigerant trapped in the system. We don't want to slug our vacuum pump. I'll do the same thing on the, well, that was actually the high side, so we'll do the low side now. No movement on the gauge, we're good to go. So both gauges are into a deep vacuum. At this point, we'll do our standard evacuation process, generally about at least 15 minutes. Good indicator on these gauges is going to be our reference needle. It will allow us to know when we've pulled down to a deep vacuum. If we can get to the ultimate vacuum of our pump, we know that this system is fully recovered. If you have a micron gauge, you can always hook a micron gauge to the system, which is recommended, so that you can get a stable 500 microns of dryness in your system. Again, our evacuation will take approximately 15 minutes, and we want to make sure we don't see any rise in the system. Generally, after pulling for about 5 minutes on the system itself, I'll go ahead and do another standing vacuum test so that we can see that the system itself doesn't have any leaks. Because we've done repairs on this refrigerator. We put some Lokring connectors on to put our process ports in. So essentially, we want to test all those connections as well. So I'll do another standing test on the refrigerator and make sure, again, I generally wait at least 5 minutes and make sure that we don't have any rising vacuum. Don't see any rising vacuum, so we'll continue with our evacuation process. And that's done by simply opening the valve back to our vacuum pump and allowing the system to continue to evacuate. Again, the whole time this operation is going, we still have our fan running, and we're still monitoring for leaks using our leak detector over here. All of those devices should be in place while you're performing this service. Okay, so we've completed the evacuation process, and at this point we can move forward with the charging of our unit. Everything is going to stay hooked up exactly the same. The only thing we'll change is we're going to go ahead and close our liquid side of the system because we're not going to be charging liquid at this point. So now we can go ahead and secure our ball valve for our evacuation hose and go ahead and shut off the pump. And at this point, we can shut all of the valves on our system. By shutting all the valves, we're essentially saving all of the vacuum inside. We're guaranteed that we're not going to lose our evacuation. We shouldn't have any leaks. So this is the reason I shut all the valves. We'll be charging in a vapor today. We'll have our scale here. We'll zero out our scale. Currently have it set to ounces so that we have 1.2 ounces of refrigerant of R600 needed for this unit. So we'll be delivering it from our bottle through our check valve, which our direction arrow is pointing away from the bottle. So refrigerant flow will be from the bottle towards the unit. And then I just take the check valve and sit it in the kit. And that helps prevent the scale from being moved around a lot. And we can get a more accurate reading. Try to keep it in the same spot. Some technicians actually put a blue or a circle around here so they can keep their cylinder in the same spot every time. And after we moved it, we want to zero it. So at this point, we're able to open our refrigerant bottle, and we'll go ahead and deliver the gas through our suction side. So I'll go back and reopen our suction side and our suction side manifold, and then we'll regulate everything from right here as we push our charge in, looking for 1.02 or 1.2 ounces. And once we get to the point where we don't see any more refrigerant being drawn in, we'll actually turn the unit on and allow it to draw the remainder of the refrigerant in. Prior to doing that, I will secure my refrigerant inlet valve and then turn on the refrigerator, which it does have a slight delay, so we'll have to wait for that to kick in. Once that gauge starts to come down, and we'll open up our refrigerant flow again. Once we get close to the full charge amount, we'll start to close our valve and meter it in, just allowing the scale time to equalize between little charges. And this will allow us to ensure we hit the most accurate charge we can, which is 1.2 ounces. So we're at 1.0. One.
Can we get the red one as well?
It won't change right now. Shouldn't be. And we hit 1.2. Now, if we're troubleshooting, we want to see the high side gauge. We'll actually have to get a high side reading, and we'll need to do that by actually opening our Schrader core depressor. So we've hit our 1.2 ounces of refrigerant into our refrigerator. So at this point, there's still going to be refrigerant inside my charging hose, and the blue charging valve is closed. So I need to get this tiered amount of refrigerant into the unit, and that's simply by closing the refrigerant bottle or our bottle adapter and closing this valve. Now no more refrigerant can escape the bottle. So once I open my charging valve, we should see a little spike on the low side gauge, and then the remainder of the refrigerant is pulled in. And we close our valve. And now it's safe to disconnect the bottle from our bottle adapter. So at this point, we've identified that our high side is operating at a correct pressure here. We have 70 PSI on the high side, which is very typical for a small R600 unit. At this point, we're ready to disconnect. So I need to come to my high side gauge, and I just need to back seat my Schrader core depressor. And then remember, there's a void here. So if I fully back seat, I won't get the little bit of refrigerant that's going to be caught between the fitting and the actual stem of the Schrader core depressor. So I'll simply turn it in about a quarter turn. That'll open this area up, allowing me to recover all of the refrigerant. So we'll come through. I'm already tied to my suction side. I'm still reading. My suction side is still open from the charge process earlier. And all I want to do is slowly crack this open and draw all of the liquid refrigerant out of my gauge manifold. It should essentially match my low side gauge. Once we're in a vacuum like this, I can simply backseat my Schrader core again. I can isolate my valve manifold, and I can remove the Schrader core depressor. Always put your Schrader cap back on if you're going to leave the process stubs in place. If you want to permanently leave these in place but render them useless to a homeowner or another technician, or for R600 liability and safety, you can always put some lock prep into the end of the Schrader core and onto the threads and install the Schrader cap, and you have just rendered that port unusable and would be just as good as if you would put a stopper on the end of the process too. If you like to leave the Schrader cores here for future services, that would be up to your company policy. I'd like to thank everyone today for watching our training video, and I'd like to say a special thank you to Sub-Zero for supplying the under-counter refrigerator that made this video possible. I also hope that the information that you've learned and gathered in this video is going to be beneficial to you in the safe handling of hydrocarbon and other flammable refrigerants.
Okay, everybody. Thank you very much for your attention to that. Give me just a second. I've got to stop the video. Okay, we've got the video stopped. Okay, so one of the things that that we need to actually sit and talk about for a minute. You noticed how he metered how he metered the flow of the refrigerant into the system, and then whenever he got done and he had reached the correct amount of refrigerant that he had to get into that refrigerator. Notice that one was actually in ounces. Many of the ones that you're going to find, especially especially if it's a non-American company, they will have it in grams, not in ounces. So that's something that you need to be able to know what I'm doing, because there's a big difference between grams and ounces. And I need to, on my scale, I need to have ounces and grams and determine which one off the model serial tag I need to use. So that would be what I needed to do. Okay. Since I have this numbness going on my whole right side of my face, I'm going to go ahead and go and get um, one more video started because I can already tell that I'm dribbling, so it's not a good thing for me right now. So I'm going to go ahead and use the GE Lokring seal system repair. Okay, so let me go right here. Come back over here to present. Here we go. Okay, share. And
my name is Jeremy Hedges, and I'll be guiding you through the repair of a GE refrigerator with a top mount freezer that utilizes R600A refrigerant. So as you can see, we have all our equipment, including the new evaporator, laid out onto our workbench. And the first thing that we'll do is we'll take an abrasive cloth and we'll clean any of the contaminants and oxidation off of the copper stubs.
I'm dribbling out the side of my mouth.
We're trying to preserve as much of the copper tubing as we can. So we'll clean
Dr.
all the way to the
Welch
apex of the bend, where eventually we'll mark it with a Sharpie and make a cut using our LRSZ 120-degree tubing cutters. So we have to clean both sides, obviously. It's the same preparation that you would prepare for a brazing operation, except in this case, we're going to leave the factory braze joint intact. Since it's not leaking, we're simply going to remove the bend, leaving parallel tube intact so that our service connectors can then join the new evaporator to the pre-existing tubing inside of the unit. Here we're marking where we're going to make our cuts. Again, you just want to get as close to the apex of the bend as you can. You don't want to leave any of the bend because of, near the tube, there's going to be a slight pinch, and that's going to cause ovality. So we're cutting where the tube is nice and uniform and parallel, and it's going to ensure that we have a nice fit with our service connector. Here, Bill's using our LRSZ 120-degree cutters. Notice an overhand grip, which keeps his arm very nice and straight. Since these cutters don't have rollers, this is one of the techniques that'll help keep you perpendicular to the tube while cutting it. Don't cut all the way through the tube. It's only necessary to score it and then snap the remainder of the tubing off. This will also ensure a clean cut and that we have less burr or need for deburring of the tubing. On occasion, you may not have scored the tube quite enough, so just bring the tool back in, line the cutting wheels back into the groove you've already made, continue to cut, and then you'll be able to snap the tube off. Take a little abrasive cloth just to clean up any tooling marks or anything that may have remained. If you were barehanded, it'd be getting any oils off. Again, it's the same contaminant requirements that you are typically used to finding when you are performing a brazing operation. So the next maintenance we'll be performing is the removal of the faulty evaporator. Again, we're going to start with some abrasive cloth and clean all of the copper tubing inside of the unit. The factory brazes in this scenario were not faulty. This allows us to maintain all of the copper tubing that's inside the unit. This serves many advantages. One, it leaves you plenty of tube to perform your main repair. However, should you have an assembly incident or you had a faulty assembly, you still have some tube remaining for a second repair. This is always something that you try to teach and have technicians thinking about, leaving more copper tube than is necessary. Often, if you think outside of the normal brazing standard or location where you would braze, with Lokring, we can generally have a condition where we leave the unit with more tube than we started with. So again, this is beneficial for your main service that you're performing, or if for some reason something goes wrong, you still have tube to recover and create a second repair. And here you can see Bill's again using the LS or LRSZ 120-degree cutters to cut as close to the aluminum stubs as possible. This again is giving us that additional copper tube that'll help us for our repairs. He scores through and cuts it away. We'll cut both sides, capillary and suction sides of the evaporator. And then after it's cut away, all we have to do is simply remove the old evaporator. So once we have the old evaporator out of the way, we can bring our new evaporator into the unit and install it back onto the mounting hardware. Installing it back onto the mounting hardware will make the assembly of the service connectors much easier. It'll allow you to push against the evaporator itself to make sure that you're maintaining insertion depth of the service connector while performing the assembly. Here you can see Bill is kind of preloading the tubes, very similar to what you do with brazing, where you want to get a slight bend so that they stay inside the coupler, in this case inside of our 0, 0 connector. Make sure we have all of the wiring out of the way before we get into assembling the joint. So in this case, since the evaporator inlet is towards the back, we'll perform that repair first. With the tubes preloaded and test fitted the connector, we can now go ahead and prepare for our permanent connection. So you'll put the connector on, apply some lock prep, rotate the connector. Now we'll go to the other side of the tube, slightly fitted into the connector, add 2 drops of lock prep, insert the tube fully, rotate the service connector to make sure the lock prep is coating the entire tube. Here, Bill's using his left hand, his static hand, to push the inlet to the evaporator against the evaporator itself to maintain that insertion depth. Once you've had a couple compressions of the hand assembly tool, you can then slide your hands towards the back to complete assembly where it's more comfortable for the technician. And as you can see, the joint is completed. On this connection, Bill is going to remove one of the rings. So the rings on our connectors are removable. They can pop off utilizing a pair of pliers. A twisting action very similar to opening a bottle top will remove them. We often do this if there's a bend near the connector because it'll actually shorten the profile of the ring. And in this case, it's allowing him to put a little extra pre-tension by shortening the body of the ring just from removing the ring itself. Again, he applies his lock prep, puts the connectors on, brings the other tubes in line. You can see the ring's a little loose. So now he's got the ring back away, and he'll apply the lock prep directly to where the body and the insertion tube join, and then push the tubes back together. The ring slides right back into place. Rotate the connector, ensure good distribution of our lock prep, and again, bring your hand assembly tool into the unit, placing most of the force against your static arm, and you can slide back and begin the compression or complete joining of the service connector. In this scenario, Bill changed the direction of the tool. He switched from right-handed to left-handed because he has a lot more room towards the center of the cabinet to actuate the tool. After you've done those first couple compressions, the tubes are locked into the connectors and it's safe to move your position. So we're going to begin the compressor removal by cleaning the copper tubes just like we did when we did our evaporator installation and removal. Again, we're going to clean the copper tube where we're going to make the cut. So in this case, for the compressor discharge, there's adequate amount of tube, right straight tube, at the compressor stub itself. So Bill only has to clean fairly close to the original compressor joint. After he gets everything adequately cleaned, he'll bring in the LRSC 120-degree tubing cutters and cut the joint as close as he can to the compressor. Obviously, with the condenser or the outlet of the compressor, the epoxy coat that can be on those lines can take some time to get off, as are represented in this video. But now, as you can see, Bill's back with the LRSCs, and he's keeping that straight arm technique to cut into the steel line, ensuring you're getting a nice perpendicular score mark. But since we are dealing with steel, sometimes in a tight location, you can use a pair of pliers to actually twist the line to help snap that score, which is what he's doing here. And he's able to break it free nice and clean. Next, we'll go ahead and clean the suction line before cutting it. But if you notice this line, it has very immediate sharp bend as soon as it comes out of the compressor stub. So there's not enough tube present for a service connector to be mounted right where that bend is. So Bill has chosen to go directly under the apex of the bend at the first available straight portion of tube. So he's going to clean that portion and then make his cut accordingly. Again, keeping that straight, stiff arm motion, keeping his wrist parallel to the tubing itself. That's going to ensure a nice straight cut. And again, it picks up the pliers to help bend and flex the tubing, and it should snap right off. It's like the compressor pan was interfering slightly with removal of that tube. And next we'll transition to removal of the dryer. So again, same process, cleaning our tubes to begin with. Again, you see Bill's cleaning the tube as close as he can to the dryer. There's not much of the heat loop available coming out of the cabinet, so you want to maximize as much of the tubing as you can. Again, you can see how Bill really tries to maintain a straight, perpendicular motion to the tube. Dryer snaps off cleanly. And then next we'll use capillary tube cutters to cut the capillary tube as close as he can to the dryer. So prior to installing the compressor or replacement compressor into the unit, we're going to go ahead and install a process tube right here on the workbench. So Bill is cleaning the new process tube port on the compressor with abrasive cloth. And now you'll notice he's popping the ring off. And the reason he's doing this is because this is a vertical down connection. He wants to make sure he gets the lock prep all the way at the top of the joint and coating the entire tube. Gravity's going to want to fight against you on this. So pulling the ring away lets you see exactly where you're applying the lock prep. Here for the top tube, gravity works with you. So he's applying it to the base of the tube and inserting it fully into the connector. You still need to rotate. You notice the ring slides right back up into place, and he can complete the connection. Don't really need to maintain a pressure on the process tube. Gravity is keeping it against the internal stop, and you just keep going until both rings are in contact with the center stop and the joint's complete. So now we can remove the faulty compressor from our unit since we cut it away previously. And now we can bring in the new compressor with the process stub already installed. Now again, it wasn't difficult to install this process tube on this particular unit, but it was just nice to get it out of the way and perform that service on the workbench. So to complete the install, we'll go ahead and clean our compressor discharge and suction ports, ensuring to remove all the oxidation from the copper tubing. So with all the tubes completely cleaned, now we need to bend our condenser or compressor discharge line. We also will need to reshape and bend the suction line. So Bill's going ahead and working with the compressor discharge to condenser, and he's placing the service connector onto the condenser line and then placing everything onto the compressor, checking for interferences. In this case, the condenser fan itself is an interference. So he just wants to pre-bend the tube, make sure everything fits nicely before we start our install. And he's going to move to the suction line, which, as you can see, does require quite a bit of reconfiguration of the suction line. And that's because the process tubes or ports on our compressor are in the vertical position now instead of horizontal. There's still plenty of suction line to allow for this repair, as you can see. It just takes some manipulation of the tube to get everything to fit into the connectors and line up with the compressor. Again, in this scenario, Bill's pulling the ring off of the connector, and you can see that it doesn't even want to go up the tube. And that's because, again, being so close to a bend, there's some ovality there. So by removing the ring off of the body of the connector, he's able to visually ensure and feel that he is in the internal stop and that that bend isn't binding on the ring itself. So everything is fit. He's got everything test fit, good to go. We have no interferences. So at this point, he can begin to make the permanent connections. He's going to remove his connectors, get everything situated. I'm going to pop another ring off the body. So now he has the compressor stub is place the body of the connector. Both rings are separated. Again, since these are mainly pretty much another vertical down connection, he wants to ensure that he can see where he's applying the lock prep. So by pulling the rings off, you can do that. Now he'll lift the body up slightly off of the port on the compressor and apply the lock prep, and then lower the body back down. It's like he's going to add a little bit more and rotate. Must have had a little bit run down the process tube. Now he'll place his ring onto the tube and insert the condenser tube into our body of the connector. Again, lift your ring, pull the tube back, and apply some lock prep. So you're going to apply it directly to the insertion tube and against the body of the connector. And this is showing the another angle of the install. Again, rotating the body, making sure both tubes are inserted. He's going to lift the bottom ring up a little bit to get it to seat onto the body. And now he'll bring the assembly tool in. Again, in this case, his static hand is on top. That's allowing him to put pressure on the condenser tube and keeping it pushed into the compressor itself. That's one of our main failure modes, is not maintaining insertion depth. So it's important to put that positive pressure on the tube and ensure that it remains inside the connector at all times. Again, after a few compressions, you can flip your tool over where you have more room to complete the connection. We're going to apply lock prep to the suction line now. So again, he's got the ring separated, lifts the tube so that he can vertical down connection, make sure he gets plenty of lock prep right at that interface between the body and the tube itself. And again, static hand is holding down on the suction line as he compresses the connection. Now that he's got some compressions, he flips it over where it's more comfortable, and he gets much longer stroke on the tool because he's no longer hitting the compressor pan. And the joint's complete. Take a rag and remove any excess lock prep from the connections. now that the compressor has been installed, we have one last component, our filter dryer. In this scenario, there was a defect in the capillary tube. It had a slight pinch, which allowed it to shear under manipulation. So we lost a substantial amount of capillary tube while performing this repair. So to show the technicians in the field how to recover from this, we're going to do a capillary to capillary tube joining and actually add a small length. So in this case, we have a 1.8 millimeter connector, so 1.8 NK MS00 connector. They do have internal stops when we're talking about the straight coupler for capillary tube. And we have to be very careful. Just a drop, just get it to just on the tip of the applicator, then insert your tubes and rotate. Capillary action will draw the lock prep in. And you can close the connection. Just like brazing operation, if you applied too much lock prep here, it could be drawn into the end of the capillary tube, blocking it off. So again, the slightest application of lock prep on the exterior of the tube between the body and the capillary tube is all that's necessary. Now that we've extended the length of the capillary tube, we can now install the dryer. But we found that the dryer was extremely long as well. So we removed as much material off the inlet and outlet of the dryer as possible so that we could reduce the overall length of the dryer and ensure that it would fit neatly into the cabinet body. So with capillary connections, you'll first apply your lock prep onto the capillary tube side. You see, basically Bill forms one little drop at the end of the applicator and then wipes it on the capillary. Now on the dryer side, we'll use more lock prep. So he's got about 2 full drops that he spreads out right there, and then we'll rotate and assemble the connection. Again, he's got his pinky is actually holding the capillary tube just to prevent it from backing out of the connection. And now we can complete the inlet to the dryer. And again, we're going to have another vertical down connection in this scenario, so lock prep application is very important. So Bill's going to go ahead and apply the lock prep from the horizontal to the bottom of the dryer. Rotate, make sure it's in place. And now he can apply the top joint. He's not going to pull the ring off since this is gravity will help, as well as capillary action, draw the remaining lock prep into the connection. And rotate the body of the connector. Maintain our insertion depth by pushing up on the dryer. Our static hand, and then we compress the connection. Now we can move our hands out to a more comfortable position to complete the connection. And that's it. Connection is complete. Remove any residual lock prep from the connector. This will conclude our presentation of the Lokring joining system for the repair of the GE refrigerator with R6.
Okay, so once again, I appreciate that your patience. I apologize with I don't know what it is that I've got, but my whole from about here from all the way over is numb. So I am going to have to go to the doctor, which is who had just called me. But anyway, let me take this off. Thank you very much. You have a wonderful day.